A body travels first half time with velocity v1, second half time with velocity v2 in particular direction. Then average velocity is how much? So I told you one formula for average velocity is equal to displacement by time taken. Suppose different displacement vectors are given. If S1 is given, S1 bar plus S2 bar plus S3 bar plus and so on by, because the total gives you total displacement, by time taken. If T1 is the time taken for S1 displacement and T2 is the time taken for S2 displacement, T3 is the time taken for S3 displacement and so on. So this is the total time taken for this total displacement when individual displacement vectors are given. So this is the formula for calculation of total displacement, and the total time taken is this. Here also is dividing the total motion into two parts. So from here to here, let us say it travels in time t seconds. So a body travels first half time. First half time means from here to here, let me take it is t by 2 and with velocity v1, and second half time with velocity v2. So this time is again half. Displacements are not same, so you can take like this also if you get doubt. So first half time with velocity v1, second half time with velocity v2. So total time is t by 2 plus t by 2. But according to this formula, average velocity equal to, here from here to here one displacement, here to here another displacement. S1 you take, S2 you take. So total displacement is S1 plus S2 by T1 plus T2. But we don't know S1, S2. So let me calculate that S1, S2 in terms of V1 and time. You know V1 is equal to S1 by time T half. So S1 is equal to V1 into T half. Same way S2 equal to V2 into T half. Means T by 2. T by 2. That's it. Now what you can write? Average velocity equal to total displacement V1 T by 2 plus V2 T by 2 by T by 2 plus T by 2 is T. So T cancel. What do you get? V1 by 2 plus V2 by 2. That is V1 plus V2 by 2. This is the average velocity. Now in the second problem, a body travels first half of the distance with velocity v1 and second half of the distance with velocity v2. Find average velocity if it travels in particular direction. So this total displacement I am dividing into exactly half of, because first half distance, so second half distance is set. So let me take, it takes time t1 for this half displacement, and for next displacement it takes time t2. So v1, this is v2, but he said this is, if this total is s, this will be s by 2, this will be again s by 2. So v average velocity equal to, what do we know? S1 plus S2 by T1 plus T2, but S1 is S by 2, S2 is again S by 2. So let me calculate this T1 value, T2 value in terms of V1 and S. What you can write? Time t equal to displacement by velocity. So S1 by 2 by V1 and T2 equal to S by 2 by V2. So S by 2 V1, S by 2 V2. That is T1, T2 values. So substitute S by 2 plus S by 2 is S by T1 is S by 2V1 plus S by 2V2. So SS cancel. What you are going to get? Here you take, this is equal to 1 by, so 2, so it comes to numerator 1 by V1 plus 1 by V2. What you are going to get? V2 plus V1 by V1 V2. So 2V1 V2 by V1 plus V2. So here I want to tell you from these two examples one thing, that most of the students are habituated to remember these formulas. Of course, so that is the formula V1 plus V2 by 2 is correct under this situation for average velocity. 2V1 V2 by V1 plus V2 is correct for average velocity under this situation. Unless you remember this case situation, you don't try to remember this formula. I have observed most of the students remember this formula, but they forget the situation under which that is correct. That's why my only suggestion is never go for remembering any shortcuts, or just take the problem and solve it. Within minutes you are going to, within seconds you are going to get the answer.